Students, our today's lesson is last topic of chapter number 5, which is motion of a satellite. Uh, Before discussing that topic, let's have an introduction of satellite and its types. What is a satellite? Satellite is that object which revolves around a celestial object. And remember that generally the word satellite is taken as taken for naturally revolving objects. So this satellite can be divided into two important categories, which are natural satellites and artificial satellites. Objects that revolve around celestial bodies naturally, they are called natural satellites. Their example is Moon is the natural satellite of Earth. Planets are natural satellites of Sun. But remember that you will not write it as Moon, because you will have to explain that Moon is the natural satellite of which planet. So Moon is the natural satellite of Earth, as all the planets they revolve around Sun, so they are natural satellites of Sun. Artificial satellites, objects that revolve around Earth and are sent by scientists. These objects are called artificial satellites. For example, satellites of Global Positioning System (GPS) or weather forecast satellites. There are a number of satellites which are also used for communication. They are also artificial satellites. So this is the basic introduction of satellites. Now, if we proceed towards the motion of satellite about Earth, then we can draw a figure which will help us in describing this motion. This is the figure which shows a satellite which revolves around the Earth. This is the position of satellite. So if this circle represents Earth, then it has radius r. And satellite is definitely at a height from Earth. So total distance will be equal to, from center, total distance will be equal to r plus h, which is, let's say, total distance is denoted by this small r, which is equal to r plus h. Now let's draw the satellite at another position so that we can easily understand this figure. Let's say this satellite is at this position, then how many forces are acting on this satellite? We know that whenever an object is moving on circular track, then centripetal force acts on it, which is mv square over r. And as we have studied in the previous topic, that at the introduction of this topic, that satellites revolve around Earth due to force of gravity. So force of gravity acts on the satellite, which is equal to mg. So these two forces are responsible for motion of satellite. So let's write their equations. That first force which is responsible for this motion, that is centripetal force. Second force, that is gravity or weight of satellite, which is equal to mg. If we put the value of force from second equation into first one, then we have mg is equal to mv square over r. On simplifying, we have g is equal to v square divided by r. We are finding velocity of this satellite, so we can write this equation as v square is equal to g into r. To simplify it, taking square root on both sides, then v will be equal to gr, where we have written in the figure that this small r is equal to r plus h. So substituting its value, then v will be equal to g into r plus h. In the figure, remember that the radius of Earth is much bigger than the height of satellite from surface of Earth. You can take it as, it's not as that clear in the figure, that radius of Earth will be almost from this point up to this one, and height of satellite will be very small as compared to radius of satellite. If let's say that Earth is up to this point, then height of satellite is almost negligible as compared to radius of satellite, the radius of Earth. That is what we have written as r is much greater than h, very greater than h, which means radius of Earth is very greater than height of satellite from Earth's surface. So r plus h will almost be equal to, will be approximately equal to r. and v will be equal to v naught. What is meant by it? That if r is very greater than h, then it does not make much difference that we add value of h into r, then r value of r will be close to r, which means that, let's say we have a value of r for your understanding. Let's say that value of r is 10,000, whereas value of h is 500 something. Then when we add this value 500 something into 10,000, that does not make very much difference. It makes, that is why we have not written r plus h is equal to, we have written approximately equal to. It makes difference, but it does not make much difference. So for simplification, we replace this term r plus h by r. And as the satellite is revolving around Earth, so its velocity is known as orbital velocity. That is why this v will be written as v naught. So that while studying this topic, we could be able to understand that this velocity is not the simple velocity when an object is moving on straight track. It is that velocity in which object is revolving around another object. That is why it is written as v naught. Also, as the satellite is at a height h, and we have studied in the topic variation of g with altitude, that when an object is at a height h, then value of g reduces, and that value of g is denoted by gh. That is what we have written, as satellite is at height h, so g will be gh. So above equation will be v naught into under root gh into r. Up to this point it is enough for you, but you must understand one important step. It must be in your mind while solving this topic, but it is up to this equation number 3, it is enough for you, that this gh, when its formula is written, which we studied in the last topic, that is gme divided by r plus h whole square. And if we put this formula in this third equation, then v naught will be equal to gme into r divided by r plus h whole square. This will be the equation. Up to equation number 3, it is enough for you. If you put the value of gh and r, then you will have the value of orbital velocity, which is about 8,000 kilometer per second or 29,000 meter per second. You must also check its exact unit, that what is the value, what is the unit when its value is 29,000, but value is 8,000 kilometer per second, which is obtained by substituting value of gh and r in equation number 3. This was last topic of chapter number 5, and now inshallah we shall have a live session, live class, and in that class we shall study exercise of this topic. Thank you.